To start, if you're interested in purchasing the Yoon Openworked Ghost, please check out my website loom-shop.com to place an order. So I've made watches with all sorts of materials like aluminum, brass, copper, and titanium, but now we're going to be working with a precious metal. So I bought this piece of sterling silver in a specific size, but like all or most stock, there's plus minus some degree of variance, so I need to find out its actual measurements. This is necessary because I'll be machining it on my CNC mill. I modeled the stock on CAD, spent many hours programming the cam, and start cutting into the sterling silver. First some facing because even though the material appears flat, it's not. So I need to make it flatter within a specified range of course, which should result in a flat dial and prevent breaking my tiny end mills and fragile heart. We're gonna go through some, not all of the major machining operations, so just know that there are additional steps done than what's going to be shown in the video. Now contouring the inner profile of the Openworked dial, and I guess you can kinda see how small those flutes are. It's like less than a millimeter in diameter, so it's delicate, which is why conservative settings are used. Oh, there we go. Here's a finishing pass just to clean up those edges. Probably wasn't necessary, but it's always nice to get the best finish possible straight out of the mill. After cleaning up those chips, the hour markers are engraved, which I'm still trying to figure out the best toolpath because sterling silver likes to leave nasty burrs. I do get rid of all of the burrs eventually with more toolpaths, but it takes a really long time overall. I need to fine tune and optimize the parameters for sure. This is a cool one. I'm machining a nice chamfer along the inner edge of the Openworked dial. This will give the dial a lot of depth and faces for light to reflect and bounce off of, which should produce a really cool effect once the watch is assembled. Everything in life is better with chamfers. All the ops shown and not shown on video get a finishing pass. We can just blast through some of the remaining ops for the sake of time, and for the super satisfying part, get all those stupid but unfortunately expensive silver chips out of the way. I give everything that's done so far a check and proceed on to the outer profile. Using a tiny end mill to profile out the dial allows me to have as little waste as possible. So I could have used like a 1/4 inch or even 1/8 inch end mill to take deeper, faster cuts, but then I would have much wider toolpaths, which would be a poor use of this expensive material. I know I hyped this up before, but chamfers really do add a lot of character to any part. It just looks and feels so much more refined. Ironically, this outer chamfer won't be visible on the dial once the watch is put together, so it doesn't serve any real purpose other than to make me happy knowing that my dial has nice features hidden away. Now after what seemed like a few minutes to you guys, but in reality took much longer, I have the dial all machined out. Obviously, this is a freshly machined part with machined surfaces, so it will need a whole lot of hand finishing work done. I want to make it clear that this particular dial and design is a prototype. I knew that this first sample would not be perfect by any means, so I'm taking a good look at what changes and improvements I'll need to make for the second run. Definitely need to adjust some feeds, speeds, spacing between certain features, and a bunch of other things. Kinda shooting myself in the foot here by putting the part under intense magnification because everything looks so much worse up close than it actually is. But I just wanted to show how much work goes into making something new. Multiple tests, revisions, problem solving, replanning, and wasted material, therefore wasted money from all the unusable prototypes. Parts don't come out of a CNC perfect, a lot of work is put into the finishing, and even programming the CNC is a lot of work. You can't just tell to print this thing and expect it to be perfect. The time spent in CAD, CAM, and setup is so much longer than the time spent actually machining. Anyways, after inspecting the part, I wanted to test out some finishing and refining steps while I have this scrap prototype available. I'm used to working with a lot of materials like titanium, steel, brass, and aluminum, but sterling silver is new to me, so I want to get a better feel for it. Sterling is a soft metal, so it's kinda easier to finish than some ferrous alloys, but is also super delicate. Takes almost no force to bend, especially this thin hollowed out dial, and can easily be damaged. Like filing or sanding can remove more material than you expect, so there's pros and cons to this stuff. It is really beautiful though. The color and sheen is different from the materials that I often handle. The outer diameter needs to be brought to dimension because I machined it slightly oversized on purpose. I made a fixture off camera to work hold the dial so I can use my lathe to turn the part. It needs to be indicated on the lathe so that it runs as concentric as possible with the spindle. Basically, the dial needs to spin perfectly relative or as close as possible to its center so that an even amount of material can be removed across its circumference. So I'm using an indicator that measures down to 0.01 millimeters, and it's currently off by 1 to 2 thou, that's 0.001, 0.002 inches. That's very small, but I want to get it even more accurate than that. Following, I take a measurement for its actual diameter, then take off a little bit of material at a time. In addition to being the correct size, the surface also needs to be finished nicely, so the grits gradually increase from 2000 to around 5000 I think. I'm starting with a high grit because I programmed the dial to be oversized by only 0.05 millimeters ish, so a constant process of roughing, finishing, and remeasuring is done. As I said before, this is a soft metal, so it's super easy to mess up by accidentally shaving off more than desired, and can easily start warping by applying too much force. Thanks to the outer chamfer I machined onto the dial, there is no real burr forming as a result. The edge is coming out nice and smooth. Measurements are confirmed, finishing methods are also confirmed to be reliable, and a last look under the microscope to see if I missed anything to improve upon. I made a bunch of notes of what to update in the second run, so I'm just going through that checklist once more. Even for a test part, the finish is looking pretty nice compared to how it was originally. Back to the CNC mill after spending a few hours, or days, I don't remember, adjusting a bunch of things. One of which being the design. The only major visible change that you guys can probably notice is the 12 o'clock marker. All the other updates, you guys probably don't care enough for me to explain it all, but I did spend a lot of time on this second revision. So again, profiled and chamfered the inner section, which went much smoother than the first run thanks to updated toolpaths and parameters. Profiled out the outer diameter, and of course a nice chamfer to finish it off. That's a very simplified and condensed version of the machining. Overall, the second run went much smoother because I made a lot of improvements and somewhat knew what to expect. The surface finish straight off of the mill is a lot better, but of course still far from done, and the small design changes I made here and there turned out fantastic. Even so, I still have more notes on things that I want to tweak, but at some point I just had to go with it because this video would never end. Just know that improvements are constantly being made even after this video. Now we're gonna put the dial away for a bit to work on a necessary side project. Here's a stock of 6061 that I'll be using to make a new dial fixture. Currently the dials do not have any dial feet to keep them on the movement, so I'll be making a fixture to precisely locate and fixture my dials on the work coordinate to mill out spots for dial feet. Just some basic cam, facing, profiling through 2D, 3D contours, 2D, 3D adaptives. You guys probably don't care about this, so I'll just say that again, a lot of work goes into what seems like a simple part, like fixtures for the mill, lathe, and even my laser when I think about it now. Let me know if you guys care about any of this stuff so that I can either continue or not mention this stuff in coming videos. I'm just a big nerd about all of this, and if you are as well, please consider becoming a channel member because I film a lot of content like this for my channel members. Memberships directly support this channel and allows me to continue putting out interesting content, so I really appreciate it. If not, that's cool too. I'm gonna take a break from talking so much because I can literally feel my voice dying out, so here's some Zen machining clips. Here's the basic fixture almost done. I have all the features machined out and now need to work on these screws. These button head screws could be used as is, but I designed this fixture so that the heads will be recessed. This is just for added safety because I don't want my MOs to accidentally run into them when I'm not paying attention or make some stupid mistake. Plus, it just looks much nicer, and unfortunately, that's the reason why I do a lot of pointless things. Just some very quick turning on the lathe to bring down the diameters, so I'm not too concerned about how nicely finished they are. These are just fixturing screws, so I'm trying to bang them out as fast as possible. Now I could have stopped right here and called it good, but I couldn't live with myself if I didn't chamfer the underside of these screw heads. It will be a lot less pokey to handle and sit nicer on the fixture. You can see what I mean about it looking a lot nicer recessed. So finally, the fixture is mounted onto the bed, work coordinate is probed, offsets are checked, and a test dial is mounted. I wanted to first make sure that everything works properly, so I'm just using the first or initial test dial here because I'd be very sad to mess up any of the nice updated second run dials. I know that dial fixturing method looks barbaric, but trust me, it works, and I couldn't be bothered to do another side project to make a proper top clamp. I already have one made now, but at the time, I just wanted to get the first watch done already. So the fixture works very well, thankfully. I did tweak some more settings after this test to improve certain things, but I feel confident enough to mount on a second run dial. The dial shown on screen is the test piece, so I didn't spend any time cleaning up the feet and whatnot, disregard any sloppiness. One of the major changes made to the dial feet design was the diameter of the middle section, so where the head of the feet makes contact with the dial. The initial design was much larger than it needed to be, and I didn't want the dial feet head to be too visible from the side profile. I wish I had a collet small enough to fit the feet, but I don't yet, so I have to live with using the 3-jaw chuck. Alright, enough machining and part fabricating. I finished up the dial, left a nice semi-satin polish finish, and installed it onto the movement. I didn't want strictly a polish finish nor a satin finish. I wanted something in between so you can still see some of the satin marks, which creates the effect of satin finishes, yet polished enough to be slightly reflective. I'll explain more about this once the watch is done. So the sterling silver Openworked dial is set onto the skeletonized movement, and I begin setting each of the hands. First, I'll line up the hour, set it in place, give it a clean, and repeat these steps for the minute and second hand as well. The video is quite long enough, so I won't show the entire build process. I already showed this on my original Openworked video, so please check that out if you want to see the entire Openworked assembly process. As a reminder, if you're interested in purchasing this watch, a custom Seiko mod, or want to get your existing watch customized, please check out my website, loom-shop.com. Links to place an order and pictures of some of the watches that are built for customers can be found in the description box below. Here is the first prototype of the Yoon Openworked with a sterling silver dial. The official name is going to be called the Yoon Openworked Ghost because of the way that the dial responds to light. The sterling silver dial is a mix between satin and polished finishes, so you can still see these satin lines, yet it's polished enough to be slightly reflective. This causes the dial to appear gray and satin, almost slightly matte even, when light shines directly at it, but at different angles, the face can also appear temporarily dark. This is kind of like how black polished surfaces can appear black or pure white at certain angles. So this darker angle or inversion of the dial creates a really cool contrast with the brighter, satin, kind of matted silver engraved hour and minute markers. Also, the inner chamfers or bevels on the dial also add to this contrast because those surfaces are reflecting light at various angles. In short, the watch dial can appear either light and satin throughout, or dark and contrasty depending on the lighting situation. I'm trying my best to describe this dial, but hopefully through these shots you can see and better understand what I'm getting at. This is one of those watches that just look much better in person despite how hard I tried to do it justice on camera. Now the movement is actually in a darker gray or gunmetal color, so it does contrast well with the floating hour markers. Combined with the polished handset, the Openworked Ghost, despite how it looks and is named, is actually quite easy to read. Everything is primarily gray and silver, but at different brightness levels, so I've never had issues regarding legibility. It's basically as if the movement is black and the hour markers / hands are white. Sterling silver is also generally a warmer looking metal opposed to the cool hue of stainless steel and titanium. Okay, enough of the dial nonsense. For some basic specs, the diameter is 40mm excluding the flared out portions, a very wearable 46mm lug to lug, 20mm lug width, and only 11mm thick. The hands are filled with C3 Superluminova, and I could also put lume on the hour markers, but I chose not to because I really like the look of the watch as is. I'm tempted to use non-lumed hands as well, like a see-through design of these hands, but the channel name is Loomshot after all, so I'll just leave a little bit on there. Maybe in the next video I'll make some custom hands as well. On the Openworked Ghost, I put on a polished chapter ring that creates a really cool effect with the hour markers. You can see the reflection of the hour markers on the chapter ring, so the nice even symmetrical design continues all the way up to the edge of the top sapphire crystal. As a nice finishing touch, I engraved the Openworked model name at 6 on the chapter ring. It's there if you want to see it, but for the most part, it kinda just blends away on the rest of the face, so it's not distracting by any means. Of course, the case back is engraved with room for any additional custom engraving. The text is raised and shiny, the outer edge is recessed and matted. The crown is also engraved. On screen, it's shown with the end-link fitted rubber strap, which is my personal favorite, but for this Ghost model, the bracelet also looks really cool. Silver, gray, everything at this point. Like I mentioned earlier, this is a prototype and I do have more improvements and adjustments made to enhance this watch, but overall it turned out really nice for being somewhat an early test. My clients have commissioned all sorts of openwork colors like blue, gold, green, teal, purple, pink, etc. But I personally think this sterling silver version or Ghost edition is quite unique. Thanks for watching the video. I hope you found it to be somewhat entertaining. Let me know in the comments below what you think about the Openwork Ghost. Give the video a like, subscribe, and I will see you guys in the next video.